Okay, so let's get to how we add and subtract fractions with different denominators, okay? When we have fractions that don't necessarily become equivalent as easily as some of the other ones we've been looking at, okay? Now, a great example of this is 1/2 plus 1/3, okay? Because what is different about these, right, is if we come down here and say, okay, 1/2, and I want to get something 3. Well, we can't really multiply anything super easily without getting kind of weird fractional multiplication to get from 2 to 3. Okay? Same thing. We can't really get from 1/3 to something out of 2 super easily, right? So this strategy doesn't actually work every time, as we see. So what we have to do in this case is find what's called the least common denominator, or you may have heard in class this called the least common multiple. Okay, multiples. Okay, multiples are just when you basically skip count. Okay, so if we skip count by 2, we have 2, 4, 6, 8, 10, right? And then let's skip count for 3. 3, 6, 9, 12, 15. And this could go on forever, right? But usually it's actually a good idea to just do maybe 3 to 5 at a time, right? Really 3 at a time is good because you might get a match, okay? And what you're looking for in order to find the least common multiple, okay, we need to find the number that they have in common that's the smallest. Okay, so 6 is what they have in common. Okay, again, let's think about that phrase, least common multiple. Like a lot of things in math, okay, the names of these things, right, can seem a little advanced or fancy, right? But it's very descriptive, right? It's the smallest number, the least, okay? The smallest number that are multiples, okay, for skip counting, that they have in common, that they share. So this is 6, okay? So this means we need to change both of these fractions, okay? So we'll start with 1/2. So what would 1/2 equal with a denominator of 6? Well, whatever we do to the bottom, we need to multiply the bottom by 3, okay? We do to the top. So 2 times 3 is 6, so 1 times 3 is 3, okay? So our new fraction is 3 out of 6. Let's do the same thing with 1/3. So 1/3 is equal to, all right, well, what out of 6, right? Because we both want to get both of them out of 6. So to the bottom, we multiply this by 2. Whatever we do to the bottom, we also have to do to the top. So our new fraction is 2 out of 6, because 1 times 2 is 6. So our new problem, therefore, is 3/6 plus 2/6 is equal to 3 plus 2 is 5, and then our denominator stays the same, 5/6. And that is our answer. 1/2 plus 1/3 gives you 5/6. You just have to change 1/2 into 3/6. Then you have to change 1/3 into 2/6. Now again, the way that we knew to use 6 is because this is the smallest number that they have in common. So it'll work. All right. Now this is a long process, but I want you to try one of these on your own. So let's do 4/5 plus 1/3. All right. See if you can figure that out on your own. Okay, so what we should have done to start is say, all right, what are the multiples of these numbers? All right, so let's do that. Let's do 3 at a time. 5, 10, 15, and then we have 3, 6, 9. Any in common so far? Not yet. Now, one trick is that we're at 9. That's a lot smaller than 15. So if you keep going like back and forth, right, it actually wastes time. So let's try to catch up in case there's a match. So let's do a couple more. 12, 15, and indeed, we did have a match there. So we have 15, and you don't need to go any further, right? Once you have a match, you're kind of all done. So that means our least common multiple, or our least common denominator, is 15. All right, so let's get our new problem. Well, we have 4 out of 5, and we want to make that have a denominator of 15. All right, so what did we need to multiply 5 by to get 15? We needed to multiply by 3. So 5 times 3 is 15. Whatever you do to the bottom, you also do to the top. So 4 times 3 is 12. So our new fraction is 12 out of 15. All right, now let's take 1/3. And how do we get 1/3 and have a denominator of 15? Well, we need to multiply 3 by 5. Now, whatever you do to the bottom, you also do to the top. So 3 times 5 is 15. 1 times 5 is 5. So our new fraction is 5 out of 15. So this leads us to our new problem, which is going to be 12/15 plus 5/15. 12 plus 5 is 17. And then the denominator always stays the same, so 17/15. And this is actually our answer. Now, you probably will notice that our numerator is bigger than our denominator, okay? This is what's called an improper fraction. There's another video on this. We're not gonna go over this right now, but just know that this is called an improper fraction. And another way that you can write this is using a mixed number, which is 1 and 2 out of 15. But again, this is gone over in another video, so we'll save that for that context. But again, all we did here is we made 4/5. We changed it to 12 out of 15. And then we took 1/3 and changed it to 5 out of 15. And this gave us 17 out of 15. Okay. Let's do a subtraction problem. So say we have 3/4 minus 2/5. Try that on your own. All right. So hopefully we said, all right, what are our multiples of 4? Well, we have 4, 8, 12, 16. Okay. What about 5? 5, 10, 15, 20. Okay, nothing yet. Let's do one more up here. Up 20. There we go. And you can begin to see how you can get a feel for how these work, right? Where it's sort of like you're catching up, one's catching up to the other, and you can get a feel for if you're about to reach one. And you can also, the more you do this process, the more you will begin to be able to do it in your head without actually listing them. But we have 20 as our least common multiple, or at least common denominator. Okay, so let's transform this problem. And we need 3/4 to become something with a denominator of 20. All right. Let me make that 3 a little neater up here for you. 3. Okay, so what do we need to multiply 4 by to get 20? We need to multiply it by 5. So 4 times 5 gives you 20. Whatever you do to the bottom, you have to do to the top. So 3 times 5 is 15. So that's our new fraction there. And then we also have 2/5 is equal to something, again, out of 20. What do we need to multiply to get 20? 5 times 4 gives you 20. So whatever you do to the bottom, you also have to do to the top. 2 times 4. 2 times 4 is 8. All right, so our new problem is 15 out of 20, 15 twentieths minus 8 twentieths. Okay, now we just take our tops, subtract, so 15 minus 8 gives you 7, and then our bottom stays the same, 20 stays the same, so 7 twentieths. And that is our answer. So 3/4 minus 2/5 is 7 twentieths. And again, all we did was we took 3/4 transformed it into 15 out of 20 with our equivalent fractions. And then we took 2/5 and transformed it to 8/20 using equivalent fractions. And this gave us a new problem where we have the same denominator, and then therefore we can subtract. And we got 7/20. 7/20. All right, let's do one more problem. And let's do one where our denominator gets a little bit higher. So 5/7 minus 1/4. Give that a try. All right, so we're going to come down here. We're going to count by sevens. 7, 14, 21. Okay, now we should already be thinking, right? Hey, this is one great example of where we kind of want to catch up, don't we? Because our 4 is going to go up by a lot less. Okay, so let's go ahead and do that. Let's catch up. 4, 8, 12, 16. See, we still haven't caught up. 20. Now we've caught up, right? So it took us 5 to catch up to the 3. That's a great way to do it. It's kind of a feel thing here. And then we have 21, 28. All right. And then 35. Let's catch back up. 20, 24, 28. Always be looking for the match, and indeed we do have a match there. It's 28. Okay. So this gives us a new denominator of 28. So 5/7 we need to have a denominator of 28. So we need to multiply the bottom by 4. 7 times 4 gives you 28. So you also need to multiply the top by 4. Whatever you do to the bottom, you have to do to the top. So 5 times 4 is 20. So we have 20 out of 28. And then we have 1/4 is equal to, all right, well, something out of 28. So what do we need to multiply 4 by to get 28? We need to multiply 4 by 7. So whatever you do to the bottom, you have to do to the top. So we multiply the top by 7. So 4 times 7 is 28. 1 times 7 is 7. So our new problem is 20 out of 28 minus 7 out of 28 is 13 out of 28. And that's our answer. So 5 out of 7, 5/7 minus 1/4 is 13/28. Okay. Now this can look a little weird, right? Because we have very different numbers here. All right. But again, it's the only way that you can do it is you got to keep splitting the pizza up into more and more slices in order to compare them and in order to add and subtract them. So 5/7 becomes 20 out of 28. 1/4 becomes 7 out of 28. And then we get 13 out of 28 as our final answer. One thing that some of you may have noticed is that a lot of times you're just multiplying 7 and 4 to get your denominator of 28. And that is true. That does work. There are some examples, and I'll show you real quick one of them, where it's doing that will kind of get you a fraction that's overly big, and it'll waste some time. So if we have 1/6 plus 5/8, for example, if we do 6 times 8, that's 48. So that would give us a denominator of 48, which is overly big, because if you do your multiples, we'll have 6, 12, 18, 24, and then we have 8, 16, 24, right? So we can actually have a denominator that's half as big as 48. Here, that's 24. That's just going to make our lives a little bit easier so we're not dealing with such huge fractions. And I'll let you continue this on your own. So what we'll get is 1/6 will become, right, what out of 24? Well, we need to multiply 6 times 4. Times 4, whatever you do to the bottom, you do to the top. So this becomes 4 out of 24. Same thing, 5/8. We need to get a denominator of 24. So 8 times 3 times 3. So 5 times 3, 15. Our new problem is 4/24 plus 15/28 24ths. And that gives us 19 24ths. That's our answer. Okay. If you had done it with 48 as your denominator, you would have gotten basically things that are unnecessarily big, right? So you have 38 out of 24, or sorry, 38 out of 48. And then you need to divide top and bottom by 2 in order to reduce, right? So then that would give you 19 out of 24. Okay, it's just an extra step and it's not necessarily needed, and it's good to be consistent in the way you do it. Okay, again, one last time, all we did here was we made 1/6 into 4 out of 24, and we made 5/8 into 15 out of 24, and that gave us 19 24ths as our final answer. All right, hope that helped. Now you should be able to add and subtract fractions no matter the denominator using this method. All right, thanks.